I'm Alexis, and I'm going to be talking to you about the autonomic nervous system. There are three types of information in our nervous system. There is the sensory information, which is information that leaves the peripheral nerves and goes to your brain. And then there's motor information, that's information that leaves the brain and goes to your peripheral nerves. And then there's autonomic information, which is the information that leaves directly from your spinal cord and goes to a specific part of your body, which is what I'll be talking about today. The gross anatomy of the sympathetic division includes the spinal cord from segment T1 to segment L2, and it also includes the prevertebral ganglion chain, which has 23 ganglions, which is also referred to as the sympathetic chain ganglion. The big difference between these two divisions of the autonomic nervous system is the pathway that the signal goes through. For the sympathetic signal, it leaves the spinal cord from the lateral horn of the gray matter, and then it goes to a peripheral nerve where it exits onto the white ramus communicans where it enters the sympathetic ganglion. In the sympathetic ganglion, where the acetylcholine neurotransmitter is released, there are four options for the signal. The first option is for it to travel up the chain ganglion and exit higher than the entry level that it entered the ganglion. Or the second option is it travels down the ganglion and exits lower than the entry level. The third option is that it doesn't synapse at all and it just exits as a splenic nerve, which is either the greater splenic nerve, the thoracic splenic nerve, or the lesser splenic nerve. And then the final option is to continue the normal pathway. After it gets into the sympathetic ganglion, it enters the gray ramus communicans, and then it goes to the anterior rami of the peripheral nerve, and then it goes into a peripheral autonomic ganglion or plexus, which is close to the target organ, and then it enters the target organ where norepinephrine is released and the target action is commenced. In the sympathetic signal, from the moment it leaves the spinal cord until it hits the sympathetic chain ganglion, that can be referred to as the preganglionic segment of the pathway. And then when it hits the sympathetic chain ganglion, that's where acetylcholine is released. And then the signal continues its pathway, and that from that moment on until the target organ, that can be referred to as the postganglionic segment. And then in the target organ, norepinephrine is released, and then target actions take place. There are 13 target actions that are related to the sympathetic division of the autonomic nervous system. There's dilate pupil, inhibit tears, inhibit salivation, increase heart rate, constricts blood vessels in the body, but it dilates blood vessels in the heart, increase respiration, inhibit digestion, release digestion, release glucose from liver, relax bladder, inhibit elimination, inhibit genitals, and ejaculation in men. The parasympathetic's gross anatomy includes the brainstem, which has the midbrain, pons, and medulla, cranial nerves 3, 7, 9, and 10, and nerves S2, S3, and S4. Okay, the parasympathetic pathway is a lot simpler than the sympathetic pathway. It starts in the brainstem and then goes to a peripheral ganglion plexus close to the target and then the target organ. It is important to remember this because this results in a longer preganglionic segment and shorter postganglionic segment in comparison to the sympathetic division of the autonomic nervous system. The first nerve comes from the midbrain, which is cranial nerve 3, which can be referred to as the oculomotor nerve. This then goes to the ciliary plexus where acetylcholine is released, and then it goes to its target organ, the eye, where acetylcholine is again released, initiating the constriction of the pupil. It is important to remember for the following nerves and the target organs that target actions that I list, that acetylcholine is released both at the plexus and at the target organ. From the pons, cranial nerve 7, the facial nerve, leaves and goes to pterygopalatine plexus, which then goes to the lacrimal gland, stimulating tears. The facial nerve also goes to the submandibular plexus and goes to the salivary glands, initiating the stimulation of salivation. Okay? From the medulla, the cranial nerve 9, also called glossopharyngeal nerve, goes to the otic plexus, which then goes to the salivary glands as well, initiating the stimulation of salivation. Also coming from the medulla is cranial nerve 10, also called the vagus nerve. This goes to the cardiac plexus, which goes to the target organ, the heart, inhibiting the heart rate. This nerve also goes to the pulmonary plexus, which goes to the lungs and slows respiration. And finally, it goes to the myenteric plexus, which leads to the digestive organs, which initiates peristalsis, which is the involuntary constriction of the intestines, and inhibits the elimination. Nerves S2, S3, and S4 from the spinal cord go to the pelvic plexus, which leads to the bladder and the genitals. The action that takes place from these nerves is the contraction of the bladder and the stimulation of the genitalia through erections. Thank you for viewing my video, and hopefully it helps you understand the autonomic nervous system better.